Hello, honey lovers. Today, we're exploring the fascinating journey of honey, from buzzing beehives in verdant fields to modern processing facilities that carefully extract, filter, and package this golden liquid. Often seen as nature's sweet miracle, honey is cherished worldwide for its floral aromas, natural sweetness, and potential health benefits. But how do bees actually create honey? And what does it take for human producers to transform it into the jars and bottles we see on store shelves? Speaking of how bees make honey, they have some of the busiest work schedules in the world. They're basically the only creatures who can say they keep office hours in the flower department. We'll dive into every step, from the bees foraging for nectar, to skilled beekeepers collecting honeycombs, to high-tech factories that refine and ensure the purity of each drop. By the end, you'll have a deeper appreciation for the intricate cooperation between nature and modern technology that makes real honey possible. Honey has been prized by civilizations for thousands of years, used for sweetening, medicine, and cultural rituals. Modern consumers continue to embrace it for its unique flavors, minimal processing, and perceived health benefits. Different flowers and environments yield distinct varieties of honey, each with its own taste profile and color. Today's honey market demands consistent quality and purity, which beekeepers and factories work tirelessly to deliver. Many people enjoy varieties like Manuka honey from New Zealand for its medicinal properties, or Tupelo honey from the southeastern United States for its buttery taste and smooth texture. These regional differences emphasize just how diverse honey can be, appealing to a wide range of global palates. Honey's story starts inside the hive, a highly organized society of honeybees. Worker bees collect nectar from flowers, storing it in their honey stomachs before returning to the hive. Through regurgitation and evaporation processes, the nectar transforms into honey. Meanwhile, bees deposit their honey into wax cells, capping them with more wax once the moisture level is low enough, typically around 18 to 20%. Beekeepers keep a close watch. They ensure their colonies are healthy, controlling pests and diseases, and sometimes moving hives to areas with abundant blooms. A thriving colony means a stable honey supply for both the bees and us. Some beekeepers even plant patches of clover, lavender, and wildflowers nearby to expand the bees' foraging options, resulting in richer, more nuanced honey flavors. When nectar flow peaks, beekeepers place additional wooden frames in hives to give bees more space to store honey. Once frames are filled and capped, they're carefully removed from the hive. Skilled beekeepers check that the cells are at least 80% capped, indicating the honey has reached the right moisture content. Harvesting too soon could yield honey that ferments or spoils. Waiting too long might hinder the bees' space to store more. It's a delicate balance that demands close observation and timing. Maintaining the bees' well-being is paramount. Some honey is always left behind, ensuring the colony's survival. Proper harvesting practices also mean less disruption and fewer stressed bees. Beekeepers often use gentle methods such as light smoke to calm the colony before inspecting and removing the frames. After collection, frames containing honey-filled combs travel to an extraction facility, often called a honey house. There, beekeepers remove any stray bees or debris. The process must be efficient to prevent contamination or degradation of flavor. Large-scale operations use climate-controlled transport or conduct extraction immediately to preserve the honey's freshness. Smaller operations might simply move the frames to a dedicated shed or room equipped with basic tools for extracting and filtering. Record-keeping systems track the origin of each batch. This traceability helps meet safety and quality standards later in the production line. Knowing exactly where a particular batch came from also builds consumer confidence, especially when honey is sold as a single origin variety. Before extracting honey, the wax caps on each cell must be removed. Traditional beekeepers might use a handheld knife warmed by hot water, slicing off wax cappings. Industrial setups use automated uncappers with rotating blades or steam-heated knives. The cappings, rich in wax and residual honey, often go on to be melted down or processed separately. Beeswax finds uses in cosmetics, candles, and other products, further reducing waste. Many beekeepers strain the leftover cappings to reclaim additional honey. The purified beeswax can then be formed into bricks for future use or sold as a valuable raw material in artisanal crafts. With the comb cells uncapped, frames enter an extractor, a large rotating cylinder. Centrifugal force pulls honey from the cells, letting it drip down the extractor's walls and collect at the bottom. Modern extractors can handle dozens of frames simultaneously, greatly increasing efficiency. Extractors are typically stainless steel for easy cleaning and sanitation. Operators adjust speed and monitor honey flow to avoid damaging the comb structure too much. Well-preserved combs can be returned to the bees, saving them energy and resources when they rebuild. Smaller-scale beekeepers might have a simple, hand-cranked extractor that spins just a few frames at a time. Large commercial outfits often rely on motorized extractors that can process hundreds of frames in a single cycle. Once spun out, honey flows through coarse filters or screens to remove larger bits of wax, bee parts, or propolis. This initial filtration is crucial for refining honey's texture and clarity. The honey typically passes into settling tanks or sumps, where it rests. Heavier debris sinks to the bottom while lighter foam rises to the top, both easily skimmed off. Operators keep an eye on temperature to maintain viscosity. Honey that's too cold flows slowly, complicating processing. Too much heat, however, could harm flavor and destroy beneficial enzymes. Some producers prefer letting honey settle naturally at moderate room temperature, preserving more of the aromatic compounds. Many medium and large beekeepers sell their honey in bulk to processing factories. Tanker trucks or large food-grade barrels transport honey under sealed conditions, preserving freshness. Proper documentation tracks batch information, harvest location, and date. Some factories do additional quality checks or blending on site to achieve consistent flavor and color, especially if honey from multiple floral sources is combined. At the factory, honey is sampled for moisture content, color grade, and potential contaminants. If everything passes inspection, it's time for advanced processing and packaging. Tanker trucks can carry thousands of gallons of honey at a time, and keeping the honey at a stable temperature ensures it remains pourable and easy to handle. Modern honey factories employ deeper filtration methods for clearer, shelf-stable products. Fine filters or microfilters remove even small wax particles and pollen. While this leads to a cleaner look, some argue it may reduce trace nutrients or unique flavors. Some brands prefer minimal filtration, maintaining a raw label. Others rely on microfiltration to meet consumer demands for crystal clear honey. Ultimately, each producer balances aesthetics, mouthfeel, flavor preservation, and marketing objectives. Many factories use specialized machinery that can filter large volumes of honey quickly while still trying to preserve its aromatic compounds. Some producers pasteurize honey to delay crystallization and extend shelf life. Pasteurization typically means heating honey to around 63 degrees Celsius, 145 degrees Fahrenheit for a short time, then rapidly cooling it. This process destroys yeast cells that could cause fermentation, especially if moisture levels aren't fully controlled. However, heating can degrade certain enzymes and delicate flavors. Many artisanal or raw honey producers skip pasteurization, focusing on gentle handling to retain honey's natural complexities. Large-scale brands often favor consistency and shelf stability, hence the pasteurization route. In certain markets, consumers specifically look for unpasteurized honey to enjoy the full spectrum of its natural properties. Honey's flavor, color, and aroma vary widely depending on floral sources like clover, acacia, or wildflowers. Factories sometimes blend different honeys to achieve a uniform taste or to create signature flavors. Lab technicians also run tests to detect adulteration with syrups or sugars, a rising industry concern. Common quality parameters include moisture content, ideally below 20% to prevent fermentation, HMF, hydroxymethyl furfuryl, levels indicate excessive heating or aging. Pollen analysis confirms floral origins. Sugar profile detects added sweeteners. Authenticity tests help maintain consumer trust, especially in markets that demand pure, unadulterated honey. Technological advances in spectroscopy and DNA analysis have made it easier to confirm the source of honey and rule out artificial additives. Honey naturally crystallizes over time, especially in cooler conditions. While crystallization doesn't spoil honey, consumers often equate it with lower quality or assume it's gone bad. Factories can delay crystallization through fine filtration, controlled temperature storage, and slight heat treatments. Some even produce creamed honey, deliberately crystallized to a smooth, spreadable consistency, illustrating how controlling crystallization can create unique products. Manufacturers may gently stir honey at specific intervals to encourage uniform microcrystals, resulting in that distinctive creamy texture. Once honey meets final quality checks, it's time for packaging. Automated filling machines pump honey into jars, bottles, or other containers, such as squeeze tubes. Plastic, glass, and sometimes metal tins are common, each offering different aesthetic and practical benefits. Labels include batch codes, nutritional facts, brand information, and sometimes tasting notes, especially if the honey is single origin. Packaging lines operate at high speeds. Sensors verify fill levels and detect any leaks. Some brands add tamper-evident seals or shrink-wrapped caps to assure customers of product safety. Proper labeling also helps customers identify flavor profiles and recommended uses, such as pairing a darker, robust honey with marinades or a delicate, light honey with tea. After bottling, boxes of honey head to warehouses. Many producers store honey in climate-controlled areas, ensuring no temperature extremes or prolonged light exposure, both of which could alter flavor and color. Distribution networks move honey to supermarkets, specialty shops, and export destinations. In some regions, local farmers markets and direct sales maintain a closer link between beekeepers and consumers. Large-scale factories, however, rely on trucks, ships, and sometimes planes to reach worldwide markets. Proper inventory management ensures that older batches rotate out first, preserving overall quality on store shelves. While most honey is sold as a sweetener, innovation abounds. Some factories produce whipped or creamed honey, infused varieties like lavender or chili, or even honey-based syrups. Others create honey blends with fruit extracts or additional spices. Honey is also a key ingredient in cosmetics, beverages, and medical applications, expanding its market far beyond the pantry shelf. Research and development labs explore ways to optimize honey's functional properties. For instance, refining Manuka honey for medical-grade wound care or developing honey-based sports gels that offer quick energy without artificial additives. In some regions, companies collaborate with chefs to design gourmet honey lines infused with herbs like rosemary or thyme, aiming to diversify how people incorporate honey into savory dishes. Environmental concerns loom large. Bees face threats like habitat loss, pesticides, and climate change. Producers, consumers, and activists stress the importance of protecting pollinators and fostering biodiversity. Some honey factories source only from certified organic or eco-friendly apiaries that avoid harmful chemicals and maintain wildflower diversity. Bee-friendly initiatives like planting for pollinators, limiting pesticide use, and supporting research bolster both the honey supply and ecological balance. These practices also resonate with consumers who value responsible beekeeping and the well-being of pollinators. Many beekeepers share local data and collaborate with universities to track bee health trends, ensuring that preservation measures are informed by the latest science. In an era of informed consumers, honeymakers adopt blockchain and digital traceability tools. QR codes on labels can link to data about the honey's origin, the beekeeper's profile, and even regional bloom conditions. This level of transparency instills confidence, especially where honey fraud is a concern. Traceability also strengthens accountability. If a batch fails quality standards, manufacturers can quickly isolate and address the problem, protecting both brand reputation and consumer safety. In regions with strict regulations, such digital systems help producers comply with audits and maintain certifications that assure buyers of authenticity and purity. Honey factories worldwide must adapt to different local requirements. The European Union, for example, has strict labeling rules regarding pollen origin. Middle Eastern markets might emphasize certain floral types or halal certifications. In the United States, organic honey standards revolve around apiary locations and pesticide-free zones. This global perspective allows factories to produce region-specific honey lines, catering to diverse tastes or legal regulations in each market. Companies that export internationally often manage multiple production lines, ensuring that every batch meets the labeling and quality demands of its destination. Honey consumption continues to rise, driven by health trends and the shift to natural sweeteners. Factories respond with more raw, unfiltered, single-origin or limited edition batches. Honey tourism emerges, with visitors touring beekeeping farms and honey houses, experiencing the harvesting process firsthand. Looking ahead, synergy with technology, like precision beekeeping using AI-driven sensors in hives, will likely refine honey production further. This could mean better colony health, higher yields, and deeper consumer trust in the final product. Some experts predict an uptick in highly specialized honeys derived from exotic plant species, offering new flavor profiles and potential wellness applications. After all these careful steps, bee foraging, honeycomb extraction, spinning, filtering, and packaging, there's nothing like the moment honey touches our tongues. Whether drizzled on toast or stirred into tea, it carries the essence of countless flowers and the silent work of thousands of bees. Each drop is a collaboration between nature's design and human stewardship. When you open a jar of honey, remember the journey that brought it to your hands, the buzzing hives, the dedicated beekeepers, and the meticulous processes in state-of-the-art factories. It's a testament to how ancient traditions and modern technology can converge to preserve one of nature's most enchanting flavors. We've just traced honey's path from hive to factory, witnessing how cutting-edge methods ensure its purity, flavor, and safety. From the buzzing environment of the honeybee colony to the precise controls of a factory bottling line, honey remains an enduring symbol of nature's bounty, protected and refined by human care. If you've enjoyed learning about this process, consider subscribing for more insights into how everyday foods are created. Hit the notification bell, share your thoughts in the comments, and next time you drizzle honey on your breakfast, you'll know the extraordinary story behind each golden drop.